Have you ever thought about how much data we deal with on a daily basis? Data is everywhere today. It powers our world. We use data to make decisions, to discover new insights, and to overcome challenges. From teaching a car to drive itself or using call quality information to build new communication networks to tracking visitors on a website, many data sets have one thing in common. There are potentially endless streams of similar events. My name is Sarita Panda, and in this short intermediary lesson, we will learn the art of expressing computation on data in a short and elegant way. This is intended for programmers who have already been exposed to basic Java 8 concepts such as optional types and lambda expressions. Now let's take a look at a concrete example. Let's say you might want to create a collection of banking transactions to represent a customer statement. You might want to process all of them to find out how much money the customer spent. In Java, this kind of processing can sometimes be rather cumbersome. Operations such as finding the transactions with highest value or grouping all transactions related to grocery shopping can be difficult to express using traditional collections. We have to implement even the details ourselves. How many times do you find yourself re-implementing these operations using loops over and over again? What if we didn't need to implement how to calculate the highest value using loops and variables and only needed to express what we expect? How can we process really large collections efficiently? Ideally, to speed up the processing, you want to leverage multi-core architectures. However, writing parallel code is hard and error-prone. In this lesson, I'm going to show you a very convenient way of doing all of this without collections or loops through the Stream API. The Stream API provides a convenient way of processing data streams built right into Java. No boilerplate or special tricks required. Not only that, it can automatically take advantage of parallelism, allowing you to handle amount of data generated by systems today in real time. Sounds good, doesn't it?
Okay, I'm going to refer to the same banking example again. And in interest of time, I have written down a few classes that I can use to show the example. So here is a basic transaction class which has two fields, a category and a value. And a category could be anything like gas or grocery. And here's our statement class, which is essentially a list of transactions. And here are some pre-added transactions. As you can see, I have gas and grocery as some of the categories here. Now, let's do a few operations on this class using the Stream API, and let's get started with looking for the largest transaction on a given month. And we will first do this with typical loops, and then we will try to implement the same with the Stream API. Let's get right into it. Okay, and I'm going to print this out now. And let's run this. Okay, perfect. Now we have the largest value as 52 right here. Okay, now let's implement the same using the Stream API. And I'm going to remove the loop logic, and we will start with return. So this is the transactions. Here's the stream. And as you can see, I have something called max. This is the method I'm going to use. And I'm going to add get value and I'm going to run this for you. Now what max does is it takes in a type of lambda expression called a comparator, which compares two values. And max is a terminal operation, which means it creates a single result from the stream. So in this case, since our value type is a big decimal, all we have to do is get value, and at the end we call get because max returns an optional type to indicate whether or not the collection is max or not. Okay, and you see we got the same value again. Now you see that big loop coding, all lines of code is now converted into one single line of code, which is much easier to read than the loop version. All we had to do was we wanted to get the max value, and there was no variable tracking or loop or edge cases of null or empty done in this case. Now we can look at a more generic way of finding values in a stream. Let's say that you want to find all the transactions that have the category grocery. So in our case, 2 records are going to be displayed, which is the one with 20.75 and the one with 2.25. So in this method, grocery transactions, what I've done is I've created a new list, and then I looped over the old list and added the elements matching our criteria to the new list and printed that out. I'm going to run this for you. Okay, so here are our 2 records of grocery that are displayed using loops. Now I'm going to change this up and use stream in order to implement the same and see how that looks. So now we are going to look at this filter method. The filter method takes in a predicate, which is a lambda expression that returns a boolean, and then the filter method outputs a new stream that contains only the element that meets our predicate's condition. In this case, our predicate condition is that the category is grocery. Since this returns a list, we call a collect method with a toList collector so that it gathers all the elements from the filter stream into a list. And let's run this and look at the response. Yes, perfect. Now the result is the same, but see how elegant the stream API looks in this case as well. Now next, let's write a method that gets the total. In order to do this, we're going to use a reduce method. I'm not going to do the implementation with loops, not that we have seen enough of that. We will jump right into the stream API, which is map and reduce. So this is the stream, and I am going to call map. So map applies a method just like for each, except it returns a new stream with the values produced by applying the method to each element in the stream. So in this case, extracting each value of the stream because we only need that to compute the total. Next, we will call the reduce method. Now what reduce does is that it takes an initial value, and in our case it's going to be 0 since the total starts at 0, and then it takes a lambda expression which takes in 2 values and produces a single value from those 2 values. So what reduce does is call our lambda expression, which in this case is the add method, since we are adding values together to get the total. And so the lambda expression will call it starting with a 0 and the first element in the stream that will produce a single value. Then it will call a lambda expression again with the result of the first call and the second element, and it will keep doing that until all the elements are consumed from the stream, and it will result in a single value, which in this case will be our total. So now let's run that and see the output. Okay, so see 75, which is the total of 20, 52, 2.25, 75, 25, 75. Perfect. So I hope you understood some of the basic operations that I taught in this class, and I hope you had a good time. Thank you.